recent times, people have started realizing the impacts of anthropogenic activity on the various climate cycles that the Earth has. In view of the growing importance and urgency required, we shall be focusing on the effect of climate change on atmospheric circulation. According to the most recent assessment of the IPCC, increases in greenhouse gases and other human-induced climate forcings would lead to warming of the troposphere, rise of the tropopause, weakening of tropical circulation patterns, and increase in tropical precipitation and other climate changes. I shall begin by talking about one of the most prominent circulation features of the Earth's atmosphere, Hadley cell cycle. The Hadley cell plays a pivotal role in shaping the tropical to subtropical climate. Its descending branch determines the location of the large-scale subtropical dry zone, and its ascending branch determines the location of the ITCZ, intertropical convergence zone. The Hadley cell undergoes a continuous seasonal migration and is subject to the influence of the internal climate variability from interannual to multi-decadal time scales. In particular, the meridional extent of the Hadley cell is found to be responsive to climate change forcings such as greenhouse gas increase and stratospheric ozone depletion. There is some evidence that the expansion of the Hadley cells is related to climate change. The majority of Earth's arid regions are located in the areas beneath the descending part of the Hadley circulation at around 30 degrees latitude. Those models show that the Hadley cell will expand with increased global mean temperature, perhaps by 2 degrees latitude over the 21st century. This might lead to large changes in precipitation in the latitudes at the edge of the cells. Scientists fear that global warming might bring changes to the ecosystems in the deep tropics, and the deserts will become drier and expand. As the areas around 30 degrees latitude become drier, those inhabiting that region will see less rainfall than traditionally expected, which could cause difficulty with food supplies and livability. The hypothesis that a decline in solar activity reduces the latitudinal extent of the Hadley circulation and decreases mid-latitudinal monsoon intensity is matched by data showing increased dryness in central West Africa and increase in precipitation in temperate zones north. In this manner, the change in Hadley cell cycle shall cause changes in precipitation over the latitudes as well as itself migrate polewards as the global temperature increases.
One of the important parts of the atmospheric circulation is the jet stream. It's what drives our weather patterns, transporting air masses and creating clashing zones for storm formation. This is the time of the year when the jet stream in the northern hemisphere makes its seasonal southward shift, sparking extreme swings in the weather such as a record rainfall in Texas and 4 feet of snow in South Dakota. Scientists have only recently begun to detect changes in the jet stream that may be tied to global warming. Unraveling the complexities of this emerging scientific research is critical to understanding where our weather is headed. As the globe continues to warm, it's already having an effect on the jet stream and corresponding weather patterns. According to the latest UN IPCC climate report, which states it's likely that circulation features have moved poleward since the 1970s, involving a widening of tropical belt, a polarward shift of storm tracks and jet streams, and a contraction of the northern polar vortex. Evidence to this are very robust in the northern hemisphere. But just as certainty builds up for the poleward shifting jets, there still remains questions about whether the jet is amplifying and promoting more blocking patterns. This is shown to us by the works of Dr. Jennifer Francis and Stephen Veris. They have shown that as the Arctic warms faster than the tropics, a lessening of temperature gradient between the equator and the northern pole slows the jet stream. As the jet stream slows, it supports a wavier, more frequent amplifying jet, that increasing probability of the extreme weather events known as Arctic amplification. Not everybody is yet satisfied by this result, and there are reasons why this is. There are some difficulties that present themselves in this case. One of the difficulties being in identifying the right mechanism to link the Arctic warming with the mid-latitude weather patterns is the lack of longer data sets. Satellite data goes back to the 1970s, but it's really only in the last 10 to 15 years that we have experienced such an increased rate of loss, hitting multiple record lows. So, studies that are based on observational data present findings that are not very robust enough to confirm the statistical significance of one factor over another.
These are some of the parts of the atmospheric circulation, but they still have a very huge impact in our climate system. These two systems leave us with a lot of questions and uncertainty. The edges of the tropical belt are the outer boundaries of the subtropical dry zones, and their polar shift could lead to fundamental shift in ecosystems and human settlements. Shifts in precipitation patterns could have obvious implications for agriculture and water resources and could present serious hardships in marginal areas. Of particular concern are the semi-arid regions poleward of the subtropical dry belts, including the Mediterranean, the southwestern United States, and the northern Mexico, southern Australia, southern Africa, and the parts of South America. A polar expansion of the tropics is likely to bring an even drier conditions in these heavily populated regions, but may bring increased moisture in other areas. Widening of the tropics would also probably associated with the poleward movement of the major extratropical climate zones due to changes in the position of the jet streams, storm tracks, mean position of the high and low pressure systems, and associated precipitations. An increase in the width of the tropics could bring an increase in the area affected by the tropical storms or could change the climatological tropical cyclone development regions and tracks. Widening of the tropics may also lead in changes in distribution of climatically important trace gases in the stratosphere. If the area over which the upwelling of air from the troposphere to stratosphere increases, transports of the water vapor of the stratosphere might be enhanced. This could lead to an enhanced greenhouse effect, including troposphere warming and stratospheric cooling, and also reduced ozone. More far-reaching changes in the climate system include the oceans and the biosphere. Because atmospheric wind and air-sea exchanges drive ocean currents, changes in the Hadley circulation may induce changes in ocean circulation. These may have important feedbacks on the tropospheric climate, marine ecosystems, including the fisheries, and the most important part, biogeochemical cycles, which have been hypothesized to lead the irreversible climate change. The relationship between the climate change and the Hadley cycle and the jet stream is a complex one with much still to learn. But this is what science is all about: establishing a hypothesis, then researching it to prove or disprove it. In the end, we will all benefit from a better understanding of our weather patterns and climate change. Thank you.